This is the ROS Developers Podcast, episode 103.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct, and today I would like to dedicate this episode to all those people there, ROS developers, that are struggling with ROS2. And you are trying to make your programs in ROS2, but still not working properly. You are struggling there, but you are not giving up. So if you are those kind of guys that are still struggling but not giving up, this episode is dedicated to you. And in this episode, we are going to learn about how to improve our programs in ROS2 and how to use some tools that can help us develop faster and better and with less trouble. So stay with me for learning more about those tools. And then also let me tell you that in case that you want to learn about ROS2, you want to improve your skills in ROS2, so that's the best option is to go to the Construct in Online Academy, where we have some interesting online courses about ROS2. We are teaching you from the basics of ROS2 using ROS2 with Python or also ROS2 with C++. And then we move forward, teaching you some other skills like ROS2 navigation or even manipulation using Move It tool. And other skills there also, all related to ROS2. Check our online academy and you will not be deceived. Okay, so now it's time that I introduce you Jaime Martin. Jaime is the CEO of eProxima, the company developing Fast DDS, which is the default middleware for the upcoming release of ROS2 Humble. He is an expert in middlewares, and as such, he leads also the eProxima membership at the OMG. And also, he is the member of the Technical Steering Committee of ROS2. Also, the responsible of eProxima contribution to the DDS standards. Welcome to the podcast, Jaime.
Hello, Ricardo. Pleased to meet you, and thank you for coming here to our offices. Let's start with the
interview. Second time. Second time. Okay, so let me start with the basics. So what is DDS and why is it so important for ROS2?
DDS stands for Data Distribution Service. It's a middleware standard of the OMG and is a middleware for a publish-subscribe architecture for real-time systems, for distributed real-time systems. DDS has been chosen by the Open Robotics because ROS2 is a distributed system. A robot is a set of sensors and actuators distributed, and then DDS is a perfect fit. DDS was chosen because it's proven. It has a lot of heritage in defense and aerospace and hundreds of public success cases, and also is highly decentralized. It's a pure publish-subscribe middleware with no central servers, in opposition to the ROS1 architecture, which requires a master.
Okay. Yes. We remember, all of us, the problem with the ROS core for stability and for our industrial applications, that this is a drawback. And then DDS is solving this problem in this sense. But so for people, do people coming to ROS2 need to learn about DDS, or they must just use it, what comes by default?
They can use it for most of the cases as it is. They don't need to know anything about DDS because it's hidden by the ROS2 API.
Like in ROS1, there was the communication mechanism that we never had to touch.
Exactly. But there are some cases in which you need some extra performance or some features, and in that case, you need to know a little bit what are the capabilities of DDS and the extra configuration to get the best behavior of ROS2.
Aha, okay. Then, okay.
For example, if you want, I can tell you about an example. So you have in ROS2 right now 2 different behaviors: synchronous behavior and asynchronous behavior. And for very long, ROS1 and ROS2 has been asynchronous, because that is a very good thing for, let's say, real-time applications. Asynchronous means that the user thread is just going to copy the data that it wants to send to the middleware, ROS2, and it's going to return immediately. So you know that it's going to be very deterministic, and that is very good for real time. And later, the middleware with other thread is going to send this message. So you require there a context switch in order to send the message.
That's in the asynchronous case.
In the asynchronous case, right? So imagine that you need extra performance and you need the lowest latency you can get. Then you need to switch to synchronous, in which your user thread is going to be the responsible of actually navigating through the ROS2 and DDS code and sending the data. That is going to be a lot faster because it doesn't require a context switching, but it's not going to be deterministic because it depends on the state of the middleware how long it's going to take to send the message. Right now, in the latest revision of ROS2, the behavior is going to be by default synchronous because the community thinks that they need this extra performance.
Okay. Then, if I have understood correctly, then in the next ROS2 distribution, the default DDS implementation that is going to come with is the fast DDS, the one that Proxima develops, and also in the synchronous mode.
Exactly.
Okay.
In the past, in Foxy, in ROS2 Foxy, the behavior was yet asynchronous.
Synchronous, okay. By default. Okay.
And now you can choose.
And now, so by default is synchronous, but we can still, if we want, change
to asynchronous.
Okay.
That is just an example, but maybe you want, let's say, you have other requirements, like, for example, persistence. And you need to set up in-database persistence. Well, you can do that using DDS, but you need some configuration. And then in that case, you need to know a little bit about the internals of DDS. But for most of the cases, just with knowing the ROS2 API is more than enough.
Okay, great, guys. So still don't get nervous about that much that you have to learn for ROS2. Just learning the basics, topics, packages, and compilation and all that. That's fair enough for most of the cases. Then what else? Let me check. So for the implementation that of fast DDS, you have recently launched the Python bindings for fast DDS. So what can we do with the?
So yes,
Wait. Yeah. Okay. Then you recently reached the version 2.6 of FastDDS. What can you tell us about it?
Well, as you know, FastDDS is the default middleware for ROS2. It's free and open source with an Apache 2.0 license. And we are always adding features to the middleware. In this last version, we released, for example, the content filter topic, the Python bindings, support for hardware security modules, conditions and weight sets, flow controllers, and a lot of bug fixes. You can check the release notes.
Okay, and tell us, for example, about these content filter topics, because we have seen a presentation by Tomoya, from Sony at the ROS World last year. but still it was not available in Galactic. So what can you tell us about these content filter topics that you have added to FastDDS?
Okay, so first of all, Sony, and in particular Tomoya, has been funding and contributing to the content filter topic. It's a common development between Sony and Eprosima.
Wow.
And, well, content filter topic, as its name is saying, allows you to filter the contents of a topic. That means, imagine that you have, you are sending, for example, temperature updates from a sensor, but you have an application that only needs to create a graphic of the temperature, and it's enough if they get just one update every 5 seconds.
Okay.
But you are sending a lot of updates.
Yeah.
per
10 hertz.
for example.
Yeah.
Right? And you don't want to send all this data and just one update per...
Every 5 seconds.
no.
¿No? Vale. ¿Qué pasa?
Para. Te
Vale.
lo estoy explicando mal.
Vale. Ok. Entonces,
No.
volvemos con la pregunta de los content filter.
Yes.
Vale. Entonces, voy desde content filter, ¿no?
Sí.
Vale, perfecto. Okay, so what can you tell us about the content filter topics? Because it's something that has been presented recently at the ROS World in the last year by Tomoya from Sony. So, and you have recently introduced in the FastDDS, so it's going to be available for ROS to Humble.
Exactly. Well, this content filter topic is a common project between Sony and Eprosima. So they have been funding us and also contributing. Tomoya was part of the team releasing this content filter topic support for ROS2. And so thank you, Sony. Thank you, Tomoya. And well, as its name indicates, it allows you to filter by content the topic. So imagine, for example, that you are sending a radar track. You are publishing the position of a vehicle or many vehicles. But there are an operator that is subscribing to these updates, but it is only interested in a certain area of the map. Okay?
Sí.
Because he is the control tower of this area.
Okay.
And then you can say from the subscriber or even from the publisher that you just want this topic with X between these
X
brands,
and,
X and Y between
coordinates.
exactly. And well, the content filter topics allow you to create a kind of a SQL where sentence in which you can say, I want this topic, but only between these coordinates, between this range. And the good thing about the content filter topic is that you can filter on the writer side, on the publisher side. So those updates are not going to be sent if they don't pass the filter. So it's a smart filter. It's not just filtering in the subscriber.
In the subscriber, yeah. So the publisher is taking into account the request of the subscriber.
Exactly.
In order
and to that subscriber is going to send just the required samples.
Interesting. Okay.
Okay.
Yeah. Oh, okay, that's interesting. That's very cool. I'm eager to see this, applying this into the applications for robots in the close future when Humble provides it. Actually, I'm going to interview also Tomoya in a close podcast in the next weeks about this subject because I found it very, very interesting. And then going to another thing is that you have recently launched the Python bindings for FastDDS. So what is including those bindings? What can we do with the Python DDS bindings?
Well, we support the entire DDS API through Python.
Okay.
So you can do everything. Well, I will say that Python is a very popular language to develop quick prototypes. So if you are using something if you are using DDS directly, because I remember you that ROS2 already come with the Python bindings.
Yes.
Then you can use for something quick Python. But if you need performance, then you need to use C++.
Yeah, okay, I do agree. I also, is what we teach to our students, is that we teach them about doing prototypes with Python, but then when they have validated something in Python that it works and they need to put into production, then it has to be on C++, because we want better performance and also stability and robustness that Python doesn't have. So Python is very insecure. You don't know until you test if your code is going to break and all this. Okay, great. So yeah, for the audience over there, then maybe you can get introduced into fast DDS and do your experiments using Python. So from now on, you don't need to be going into C++ for you are not forced to use C++ if you want to do your experiments with fast DDS. Then another question, let me see. Then, yeah, I saw on your website that you are collaborating with Ericsson to simplify 5G integration in ROS2. And then my question is that, what does it mean? So I don't understand, because for me, 5G is just a channel. And ROS doesn't care about the channel because it's just sending the information through the topics, whatever the channel is, a Wi-Fi, is a cable, is a 5G, we don't care. So what does it mean, all that?
Okay, well, as you said, 5G is just a channel, but a very special channel that allows you to set up different quality of service for different data flows.
Okay.
And you can set up this within the router. The 5G router, right? It's not only that you can set up the DDS QoSs or the ROS2 QoSs, but also in 5G you can do things like allocate a minimum bandwidth for some topic or guarantee a maximum latency for some channel, and so on. What we did is create an API to identify those channels, because in general in ROS2 you publish and subscribe and you don't care about what is the source port, destination port and things like that. But in this case, if you need to set up a specific 5G QoSs for a data flow, you can request to ROS2 to create a specific data flow for you. That means you can set up the ports, you can set up, or the other way around, you can ask for this specific topic and this pair of publish and subscribe, what is the channel?
Okay.
And ROS2 is going to answer you with this definition of the channel later you can use in the 5G router. Okay. And so, and is this identifying those channels and their configurations in the 5G by using your API? So by using our API, you get the unique data flow that is collected in 5G.
In the 5G, exactly.
The channel, and you can say in your router for this channel that mostly is a source and destination IP and port, please allocate this bandwidth, or please guarantee a minimum latency.
Okay. Yeah, so more or less I get the idea, but I think I need to practice myself in order to understand better.
Imagine, for example, that you have a good example, a command topic.
Yes.
A command topic is a very important topic.
Yes.
Because always should reach the target, and then you can allocate certain bandwidth for the command topic to have always some bandwidth available for this topic.
Yes.
Well, that's a thing you can do if you are using 5G.
Okay. Yeah, and then this could have been applied, for example, when we saw the DARPA challenge with the humanoids, that they were doing the, controlling the car, and they were remotely controlled. Mm-hmm. They were remotely controlled, actually, but then they were playing with the quality of the channel.
Exactly. If you are going to execute a command like a turn left, you need to have the bandwidth, and also probably you need minimum latency for that command. But for example, if you are sending video from the car, probably you don't need any specific QoS, and if you lost any packages,
doesn't matter. Yeah, okay,
doesn't
okay.
matter.
Okay. Now I understand. Okay, and that's the collaboration with Ericsson, right, on the 5G implementation of the routers.
Exactly. In this case, we team up together and we developed the part of the DDS API, and they put on top of that the ROS2 API.
Okay, and then is it this related to the concept of DDS router that I have seen on your website, or DDS router is something different?
It's a totally different thing.
Okay, I didn't understand anything then in that case.
Not related. Well, the DDS/ROS2, because it's also a tool for ROS2. Router is a tool to enable the use of DDS on WAN networks or the cloud.
Okay.
Because, well, DDS use a pure publish-subscribe architecture with no central servers, and that works very well on the typical LAN network.
That we have here locally or within the robot itself.
Exactly. Automatic discovery, everything is going to be very easy and work very well. But if you have cloud, NAT, complex networks, firewalls, and so on, then you are going to have a problem with DDS, because you need to route the DDS traffic. And that is why we have the DDS router. It's a tool to allow you to use DDS in a complex network. When you have a mix of LAN, WAN, cloud, NATs, firewalls, you need this kind of routing service.
Okay. Then that makes a lot of sense to me, because we had a problem in the construct. We are allowing our students to connect to our robots, real robots. So they connect from outside our facility, so they are in the countries, and they remotely connect to our robots in Barcelona, and they practice with the robots. And then, so we have the assistant working, 24 hours, it works very well, but now, recently we have been implementing for ROS2 robots, and then we had a lot of problems of connections, and we couldn't get it just for some specific configuration of the robot, then it will work. And we were a little bit frustrated. So in this case, we should use this DDS router to solve this problem, or could be one.
Could be one solution. Also, another solution is our discovery server. That is also a tool that is available for ROS2, because sometimes the default discovery of DDS, that is, everything is very easy for LAN networks. For some networks that with no support for multicast, or with routing, addressing with a different addressing in the other network, and so on, then you need a combination of routing the traffic and also provide a central service for the discovery.
For the discovery, yeah. But then the discovery, I understand, maybe I'm mistaken, but I understand that for the discovery is more for, as you mentioned, for local networks. But in our case, take into account that the students, they are in other countries, and then the computers, they are in the cloud, and then the cloud should connect to our local network and the robots that we have in it.
So, well, one thing that is going to happen in this kind of environment is that probably multicast is not going to be available.
Okay.
So you are not going to find the remote nodes, even if you have this DDS router. You probably need to set up a discovery server to have a well-known server for discovery.
Okay.
It's not the same concept as in the master of ROS1.
Yes.
Because this is just for discovery.
Yeah.
And the communication is still peer-to-peer, but
I understand. Yes. You made a presentation. I mean, Proxima, not yourself, but one engineer of your team. He made a presentation about the discovery server at the ROS Developers Day in I think it was in 2021 or 2020. 2021.
I don't remember, probably 2021.
2021, yes. Okay, so I'm telling this for the audience in case that you want to know more about the discovery server and how to use it, then you can go to that video that we have on YouTube. Okay, then what else? About something else that I wanted to ask you is about micro-ROS, which is it's a version of ROS2 for microcontrollers using fast DDS that Eprosima develops together with some other teams in a project, in a European project. But what is the current status of micro-ROS? Because I saw on the website that the project has ended in December 2022. So how operative it is? Is it? It is. Is it?
So first of all, just as a small correction because for microcontrollers, micro-ROS uses a protocol that is called XRCDDS, that stands for DTS for resource constrained, so for extreme resource constrained environments. That is the official extension of DTS for microcontrollers. It's not exactly the same protocol. Okay. So you need an agent that is based on fast DTS, but also you need this protocol.
Okay. Which is not the one that you developed.
Yes, I developed. We develop also XRCDDS. We develop micro-ROS,
yes,
and also the middleware behind micro-ROS.
Okay. Yeah.
So, well, short sentence, micro-ROS is a live project, and we are continuously maintaining and upgrading micro-ROS, so no problem at all.
Okay.
And you are right. The European Commission funded part of this project, and the support this funding was finished at the end of last year. But now we have customers. So we don't need this is not an R&D project anymore. This is a commercial project. So it's totally justified that we maintain and upgrade micro-ROS, and we plan to have a new micro-ROS release per ROS2 release. So.
Okay, awesome. So that means that you are going to have another micro-ROS release
after Rumble? Yes.
Yeah. Okay. Great. Great. I didn't know about that. That's awesome. And then it's Eprosima, the one that is taking charge of upgrading and improving it, right?
Yes. Well, we have in the European projects, we have several partners there. So, for example, the BOSS was one of the most important, PIAP, Polish Research Institute, and the Fiber Foundation. But now we are going to take most of the work to maintain and upgrading micro-ROS. BOSS is going also to do a little bit of effort.
Great.
But in general, it's going to be well maintained.
Okay, great. So we can count on it to use it in our projects. And yes. Which kind of business do you think that they might need to use micro-ROS?
So any, because nowadays a robot is a set of sensors and actuators, and many of them are microcontrollers. So it's also, for example, very typical to use a microcontroller for critical real-time operations and a companion computer for asynchronous tasks, for example. In a drone.
For example, in a drone,
In a drone is a good example.
Yeah.
They use a microcontroller for the autopilot, let's say, for example, PX4. And they have also a companion computer, let's say, for video processing or image processing.
Or for the navigation purposes. So the microcontrollers will be in charge of the control for stability and for executing properly the commands of movement, but the one that executes the navigation, that decides, go in this direction and reach that point, that would be the other computer.
Exactly, the companion computer. Okay.
Great. Okay. Then I would like to ask you about something that I heard, and I think that the audience will be interested also to know, to clarify that at Eprosima you are creating a new set of tools for ROS2. So what can you tell me about those tools?
So, well, that is totally new, and it's going to be called Vulcanexus.
Vulcanexus.
Exactly.
Okay.
We are going to have a dedicated website for Vulcanexus, and well, in our conversation, we have been citing a lot of different tools we support. Let's say MicroROS, the DDS router, the discovery server. We also have graphical tools for monitoring. So Vulcanexus is a set of tools for ROS2 we maintain and develop together. It's like a ROS on steroids. We provide a full solution, including tools for cloud, the DDS router, for microcontrollers, MicroROS, monitoring and graphical tools, such as our DDS/ROS2 monitor, and a powerful simulation solution that is totally integrated with this set of components. And well,
And what is this simulator solution?
we are going to use WeBots. Well, this is a very complete simulation tool with many unique features, and also we have a very good relationship with Robotics, the company behind WeBots, and its CEO, Olivier Michel, and we collaborate with them in many projects.
Oh, yes, okay. So it's WeBots, the simulator of Robotics. Is that
Exactly.
the one? Yeah, yeah. Okay, yeah, I know. I have used it and also even collaborated. My salutations here to Olivier. Hello, how are you doing? And then excellent simulator also. And what else can you tell us about the other things that are included in Vulcanexus set of tools?
There are many components. Actually, the components were already there. We were publishing these components already. So let's say fast DDS for ROS2 core, the ROS2 discovery server, MicroROS, and its underlying middleware XACI DDS, the new ROS2 router, to enable ROS2 on the cloud, and many more things that we were updating in a separate way. And now we have decided to group all this together and offer the users a way to install all the components at once. And that is Vulcanexus.
Okay, and they can be installed in standard Debian packages?
Sure. You can download a Docker.
Also.
A Docker, that is one possibility. And the other possibility is we have a public repo, and you can do an apt get.
Okay.
So
Well, actually now is apt install. Now is apt get is for the old guys like us.
apt install.
apt install.
And just Vulcanexus is going to take care of everything. It's going to install ROS2 and the core components of ROS2, and it's going to install all the tools you need from us.
Okay. Where can they find Vulcanexus?
Well, we have a dedicated website, and that is vulcanexus.com, sorry.
Yeah, so they can search it there. And I will put a link on the show notes of this podcast so the people can reach it clearly.
We have full documentation, read the docs documentation, and then you have a step-by-step guide to the installation.
To the install. Okay. Okay, great. Then
And this is happening this month.
when are you going to launch it? My next question.
This month. Yeah.
Which month is this one?
On April. On April 2022.
Yeah, because the audience, maybe they are listening this in the future, and then maybe they don't know. So it's in April 2022.
Exactly. We have everything in place right now, the website and the repo server and the Docker images. And we're just, at this point, polishing things. And we will present this officially in the next ROS2 Technical Steering Committee.
Okay.
And also we will announce that in ROS Discourse.
Great. Yeah, so if you are listening to this, it's already released, it's already published, so you can go to the Vulcanexus website and try by yourself. Okay, great. So let me ask you a final question, which is more about your opinion. So what do you think about the future of ROS2? So do you think that other players may be releasing a different framework that will compete with ROS2, like, for example, Tesla, who is doing a lot of noise with his humanoid robot? So what do you think about the future of ROS2?
Well, good question. I think probably the most important thing about ROS2 is community. There are hundreds of thousands of users. There are already other robotics frameworks out there, but the adoption of ROS is overwhelming. So I don't think that is going to change any soon.
Yeah, okay, yeah. I do agree. Yeah, the community is the most powerful asset of ROS2. Also that because it's very good and it works very well, and it has a lot of functionality for robots and so on. It's well thought. But the most important asset is the community, right?
Exactly. The users. The adoption. There are many projects out there using ROS1 and now ROS2. And it's not easy. They are going to migrate to a different thing.
Yeah.
It should be a lot better.
Yes, yeah, I do agree. And also, I think that this is the year of ROS2 because it's 2022. So, I mean, the next year with more tools is in 200 years. So this is the year. And we can tell you that we are receiving a lot of people requests for learning ROS2 in our academy at the Construct. And so, I expect that this is the year where everybody is switching to ROS2. Okay, then here to finish, then how can people find you and discuss the project with you? What is it?
Okay, so first of all, for Vulcanexus, just going to vulcanexus.com, and there you have everything you need to know. And if you want to contact Eprosima directly, you can reach us at info@eprosima.com or through the phone. Also, you have GitHub, and we have a YouTube channel, Twitter, LinkedIn, anything. Just visit also our website, eprosima.com.
Okay, perfect. I will put a link to all those mentioned websites, like the Eprosima one and the YouTube channel. So if you want to contact him and the company, then just go to the to the show notes below. Okay, so that's all for today. Thank you very much for coming to the show, Jaime.
Well, thank you very much for coming to our offices.
Yes, exactly. Yes, exactly. So we are now at the offices of Eprosima because I had to come to Madrid for delivering ROS training to a Repsol company. They are trying to build a robotics team there, and then I decided to take the chance to come and visit you to know more. It's a surprise about the Vulcanexus, very interesting thing, and also about the other features that you have launched, like the Python bindings, and also I'm going to pay a lot of attention to the what's the name that I wrote it here is called router, DDS router, because this could solve some of the problems that we have of our students connecting remotely to our robots based on ROS2.
The DDS router is worth mentioning that this is an effort that is also funded by Rapid Robotics. In this case, they are experts on cloud, and they have a framework, a robotic framework for cloud robotics. So it's worth to mention this. And it's a common work between both companies. And the next time it will be in your place.
Okay, that's a promise. That's a deal. That's a deal. Jaime, thank you for the interview.
No problem.
Okay, and that is all for today. So thank you very much for listening to this podcast. Remember to give us 5 stars on Spotify, iTunes, or wherever you are listening to this podcast. We would like to hear also your feedback. In case that you want to let us know what you think about the podcast, suggest some other subjects or whatever you think about the podcast, then please send us an email. Contact us. You can find our email in many places around the web. Also on the website, on the notes of this podcast. And that's all for today. See you the next week with a new lesson from the experts. And until then, keep pushing your ROS learning.